Well, hello friends. Welcome back to browser hacking. Today we're going to look at requestAnimationFrame because I got a weird number of messages asking, hey, are you going to do requestAnimationFrame? And I guess we should just get to it right away. So I don't actually remember what this API looks like, so I have to look it up. So let's see. So you just say requestAnimationFrame and you pass it a callback, and then it gives you an ID so that you can cancel it. So the basic idea here is that instead of using a timer to sort of repaint your game or your animation or whatever you're doing, you can instead use this, and then you'll get a callback at just the right time interval that makes sense for your screen update frequency, or like however fast your windowing system is able to push the screen updates. And then you'd end up not painting more than you need, and you don't compute more than you need, and so on. So if you have a 60 FIPS monitor, you're supposed to get like a 60 callbacks per second. So I think that's basically how requestAnimationFrame is intended. Now, in Serenity, we don't have access to screen refresh rates and stuff like that because we have a very sort of generic display driver. But we do have one thing that we do, is that we cap the Windows server's update frequency to 60 FIPS, which, or maybe it's even 16. Damn, I forget where this code is. I'm gonna have to look for it here. In the Windows Server compositor, it has a compose timer where the interval is 1000, which is the number of milliseconds in 1 second, divided by 60. So, 1000 by 60, 16 milliseconds. So Windows Server will not recompose the screen content any more often than this. And when we originally did this, it was a huge improvement to just general system performance, because without this throttling, we were just repainting some UIs over and over and over, and that was really good. So I think what we're going to do here, since we don't have access to any information from the graphics card really, we're just going to synchronize requestAnimationFrame to the compose timer of Windows Server, because if we ever end up creating like a proper driver for something like an NVIDIA card or an Intel card or whatever, then that information would have to go into Windows Server, and then we would already have all the parts connected in a way that would make sense in the future as well, if we were to end up there with more rich information. But basically what I'm saying is, let's make the Windows Server compositor timer drive requestAnimationFrame in the browser. Yeah, so how do we do this? I guess we want you to be able to register for, I guess, like a notification from Windows Server whenever the compose timer fires. Maybe that's the easiest way to do it, because what we do is when this timer fires, then the callback will do a compose, which this is like what recomposes the screen. So maybe the nicest thing to do would be to send out the thing that generates requestAnimationFrame like right after we finish composing, because then the client program has the most amount of time available before the next chance it'll get to compose. We could also send it out right away, but if we send it out right away, then whatever logic the client does in response to it is going to compete for a CPU with compose, but maybe that's okay. Yeah, let's send it out first. That might be the better choice. Because, we're not going to be a single CPU system forever, so I need to stop thinking in this limiting ways about that. So, wait, hold on. This is the immediate compose timer. This is the compose timer. Oh yeah, so there's a second optimization called the immediate compose timer, which is something that we use if there's no compose scheduled already. Then we try to do the next compose immediately instead of waiting for the next compose timer firing, if that makes sense. But that's not really relevant right now. This one is the relevant timer. This one is just an optimization to reduce lag. So in the compose timer here, we'll say notify clients about compose. Should we call that about compose? Compose. Notify clients will compose. Tell clients notify clients will compose. That sounds like the clients will compose. Compositor will run. Okay, I think we can call it this. It was at least verbose and very descriptive, and it feels weird that we don't see the same thing before any call to compose, but yeah, I think this is okay. So what are we actually going to do then? We need to loop through all of the windows, and for any window that listens for these, we'll send him a message, basically. But we can put that, so we'll just put it down here. So compositor, notify clients, compositor will run. And this will have to go through the window manager. So window manager, for each window. Is there like a for each client? Because I just want to connect to every client. There is client connection for each client. Okay, so client connection for each client. Client notify compositor will run. Maybe this can actually be up here. Wait. No, we can have it in a separate function. I shouldn't get too worried about things like this right now. Notify clients, compositor will run. And then in the client connection class, we'll add notify compositor will run. I guess we'll take a badge for the compositor because we don't want anybody else calling this API, right? So and oh, compositor is like that. That's cool. Compositor, I think we need to include client connection here. Client connection. Okay. Now, in the client connection, not all Windows Server clients are going to care about this. So it's very important that we only send this to those who care, because this thing will be quite frequent, right? Like it's going to be 60 times per second. We're going to send an IPC message. So this thing needs to be pretty light. Notify compositor will run. So we'll say something like if listening for What should we call this? Should notify listens for compositing events, maybe? Yeah, something like that. What's the thing that they call it in Mac OS? It's called like display link or something, right? No, isn't it something like CV display link? CA display link. A display link. Display link. That's kind of a nice sounding name. Display link. But compositing event is not so bad either. Notify display link. We can call it display link. We can borrow that name from Apple. Display link. That's display link. Yeah. If it doesn't have a display link, we'll return. Okay. This will be better. Notify display link. Notify display links. Yeah. I like that name a lot. Notify display links. Okay, cool. And then if we have a display link, then what we do here is we just send, where is it, post message, window client. Oh, we gotta define a message. Okay. Close you. And we'll say display link notification. I don't know, something like that. Display link. Yeah. And it's an async message with no parameters. So you'll just get this. I think that would be pretty cool. So let's see. Window client, or no, it's messages, window client, display link notification. So there we go. And then we need to has display link false. And let's get rid of this because we took everything we need from Apple. It's just a name. Sometimes borrowing a name from somebody can help you go so much faster than if you sit there and agonize about the right name yourself. That's why so many things in Serenity has borrowed names from like Qt, from WebKit, from all kinds of places really. Those primarily, but other things I've worked on too, like KDE, and I'm sure that people who submit patches, they borrow stuff from other places. So it's a good practice, I think. Establishes kind of shared vocabulary anyway. So yeah, this is pretty good. We just need a way to actually request that the Windows server send these notifications. So I guess we can have something like, I was going to say like enable display link and disable display link. They can be async, both of them. I think they don't need to be synchronous because the nature of the display link notification anyway is that it is asynchronous, and these are never going to fail. So we'll just make them async. I should really go through a lot of the Windows Server IPC stuff and try to make more things asynchronous where it makes sense, because a lot of these things here are actually synchronous. You can see the difference between synchronous and asynchronous in the syntax. Like this here means that this request points to a response, and that means that the client will not return from invoking this IPC call until it gets a response in this form. Whereas here, this means that the client will not wait for a response. So we'll just keep going. And we have a bunch of async things, but more of them could be async. Anyways, now we're adding new async things, so that's good. And we need to actually go ahead and implement those in the Windows Server Client Connection class. So these will show up here as virtuals. Windows Server enable. Okay, please get to the Windows Server so I can get my code completion. Okay, enable display link. Response. Oh wait, no, it doesn't need a response, right? Because it's async, so it's just void. And probably it was trying to help me there. Messages. Okay. And then we just have to implement these functions. I really like the way that libIPC code generator and everything is starting to work out in Serenity. It's so nice to be able to edit these IPC files, and then you just get these functions that you can implement in C++ to handle the incoming messages. Really nice. It took some time to get it here, but it's in a good place now. So here we'll just say as display link is true, as display link is false. Okay, and that should be everything we need from the Windows Server side. And then what do we need to do in the client? Like, how do we want this API to look like? I guess we can go and look in the browser. So we'll add a function here to the global object. Call it requestAnimationFrame, and arguments. All right. So callback was the only argument. And we're supposed to return an ID, but I think we're not going to implement that right this very moment. So let's see. If argument size is less than 1, then return undefined. Okay, so, and then we'll be lazy and assert that it's a function. Just like we do up here, actually. And then I'm thinking, yeah, we can do this also, where we store the callback in a handle, which will keep it alive. And this, wait. Now we want to create a display link. So I guess we can do something like GUI. Should we just have something like this? Register. Oh, no, we have Windows Server connection. Maybe this should be its own thing, like display link, auto display link, construct, and we'll give him a like this. Register callback. Oh, I guess we can hand out an ID here, and then we'll use that. So then maybe we'll get our ID anyway, quite easily. Link ID, and I think it's going to be an I32. That's kind of a neat thing, and then this can just do exactly the same thing as setInterval does, which is just to call the JavaScript function that we stored in the callback handle. So it was pretty good. Of course, now we have to implement this API. So GUI display link. Man, I like where this is going. This is going to be a very cool API to have. Namespace GUI. And I'm thinking this guy right here, he's just gonna have something like this, right? We're not gonna instantiate display link, we're just gonna have some static helpers like register callback. Something like that. Act function. Can we do this with just forward even? Yes, we can. Unregister callback. And that will take an I32 ID. Callback ID. All right. Pretty straightforward, right? Yeah, I like it. So let's just make sure that we get our super important copyright header and that we don't lie about the years. Okay, and then we'll go to display link CPP and compress that. So callback like that, and display link. Okay, so what are we going to do here? I guess we are going to put these guys in the order in which these guys are invoked does not matter. And if you rely on that, that's your problem. So we're just going to put these guys in a hash table, I think. Or maybe even in a vector. Yeah, I can put them in a vector. It's not the most important thing in the world. The most important thing with these is to be able to iterate them quickly, I guess. But it doesn't matter which one you use. Let's use vector. Function, or let's call it Mr. callback, or display link callback. Function void callback. And we need act function. Actually, we want these to be stored by ID, so let's use a hash map. Let's use a hash map. I don't know what I was thinking there. Hash map. Hash map, but the ID could be the, no, it couldn't be the index because then it will change if you remove one. That's stupid. Alright, we're having a lot of basic problems right now. Callbacks. If we don't have map yet, then we make one. Alright, return map. Callbacks, set. And here we just need to make a display link callback, registration, move callback, and we need the ID as well here, so callback ID, move registration. And I guess we can just be a little bit lazy right now and say static callback this next callback ID. Callback ID is as next callback ID plus plus. Okay. And oh, the registration doesn't need that. Yeah. Why do I want this to be an instruct? I'm not sure why. Maybe it doesn't have to be. It could just be like that. Seems fine. Remove callback ID. Let's assert that we have it, otherwise that would be weird if you try to remove something that's not in the table. We should assert that it contains. Right. Good. All right. Now, how do we actually invoke all these guys? So we should have like display link, notify, did receive display link notification. We're going to get it from the Windows Server connection. Can even maybe just call it notify. Okay, notify, and only Windows Server connection can call me libgui forward. Okay. And then what we're going to do here is we're just going to iterate in all the callbacks and call the function. Yeah, and then we need batch. Okay, that's great. And then Windows Server connection, he's going to receive a message that we didn't implement yet. This one, display link notification. So, oops. When we get that message, handler display link notification. We don't need to look in the message, it has nothing in it. So all we got to do now is just call display link notify with a badge. Display link. Cool. I think that's might be it. This might be everything that we need. So I guess we should have made a test for this. So I'll make one right now. Call it RAF for requestAnimationFrame. And I still haven't fixed the parser to tolerate crappy documents, so bear with me. What are we gonna do in our test? I guess I'll just make a canvas. See, with 300 height, 300 fancy, and then we should have some script that does something, right? So requestAnimationFrame, and then we had a callback where we, I don't know, what are we gonna do? I guess we can get the canvas first. So document get element by ID, C, X is going to be our context. So C get context to D, and maybe we will have, well, let's see, X fill rect, C width, C height. Let's fill it up first with some black, and then X fill style is going to be red, and then we can just draw like a random dot somewhere. Math random times C dot height. Oops, shouldn't have parenthesized that. Can we do it this way? I'm so not used to writing JavaScript. It's really weird, but it is fun to learn. And then like math random times 10, I guess, something like that. So let's see if this actually works in Firefox. This didn't act the way I expected it to. Also, I didn't put the title tag. Title. So wait, do you have to call it again if you want to animate again? Is that how that works? It must itself call a requestAnimationFrame if you want to animate another frame at the next repaint. Right. So it's not repeating. So I guess it would make more sense to put this out like function ref. You would do something like that. And I messed that up. Okay. So this appears to be working, right? And it will only paint as often as the screen can update. So you'll never get more than that. Okay, so let's see if we can get this working in our browser. Starting by including the right files. So display link. So this abstraction that we just made, it doesn't perfectly fit apparently the way that requestAnimationFrame looks like. So in our case, we kind of expect it, we kind of want you to set up like a repeating callback. But the way that this is structured is a little bit, it doesn't quite match up, but it's okay. It's just, it's not ideal. So really, like after we've done the callback, we might as well unregister the link ID. Display link, unregister callback, link ID. And because if you call register inside here, you'll get a new callback ID and so on. So that'll be a little churny, and there are probably various smarter things that we can do with that. Oh shit, right, I don't know my link ID at this time. That's okay. We'll pass the link ID and do the callback instead. See? Now you know which link ID you are, so you can unregister if you like. Poof. Okay, what did we forget? Forgot to pass the link ID. Well, that means that we're going to need to iterate a little bit differently. So, callback value, call IT. Does that make sense? There we go, right. Still not good. Wait, what am I doing wrong? Oh, it's supposed to return callback ID. Oh. So I was thinking here, like, we can return whether it succeeds or not. Right now we just assert that it works. Remove doesn't return anything. Maybe hash map remove should actually tell you if it removed something or not. Might be useful sometimes. I don't know. I mean, it would be free essentially, right? Because it's inline and we have the information right here. Well, okay, I'm not going to do that right now because then I have to rebuild literally everything. So I forgot to update the name of something somewhere here. Notify client's compositor will run. Notify display links. See? And down here, of course, client is not a pointer, it's a reference. And we can't call that without a badge, so make a badge. Seems like everything is going to build, I think. Just have to wait for it to link, but looking pretty good. So how do we know if this works? I guess if it just paints the same way, right? Then we'll know that it worked. The display link API is kind of neat. So it'll give you a repeating callback by default. I think that makes more sense. Instead of like giving you a single callback and then you have to re-register for another callback. That's kind of strange. But what do I know? So what did we call it? Ref. It doesn't work. Okay. Well, wonder what the problem is. Let's find out. So request animation. So let's see. say we log that we got requestAnimationFrame with arguments size, maybe. And then we can log that we got a display link callback with link ID. Okay, and wait, are we actually? We're never starting the display link. That's the problem here. So we have to tell the Windows server to start sending the notifications. So let's see, if callbacks. I guess if the callbacks are, if there are no callbacks when we get here, then it's time to register for these things. So we'll just say Windows Server connection, the post messages, Windows Server enable display link. See how easy that was? Real nice. And then here we'll say if callbacks is empty. If it's empty, then we just disable the display link. Right, so if you're adding the first thing, then we enable. If you remove the last one, we disable. Which, this is the part that's going to get real churny, because we're going to tell the Windows server to stop sending them, and then we're going to tell it to resume it again. So this could definitely be better. And we might want to do something like having, I don't know, what would be a good thing? We could have like a persistent object in libweb that only unregisters if the new, wait, hold on. No, this is going to be fine because the callback is going to register a new display link and then remove the old one. So after the callback finishes, so we're never actually going to empty these out. So it'll stay up, the link. Should have made a link to this thing. Ref. Ooh, crash. Well, at least that's something different. So we are now in notify, and why don't you like me? Looks like it may be recently freed memory. So we are calling the callback is recently freed memory. I wonder if this is something about function objects not behaving nicely. Maybe that's why I instinctively wanted that struct. Let me make the struct again, because I think function is not well behaved. I've never tried to put a function as a value type in a hash map before, and I think this is something I don't really want to dig into right now. So we will just try this. Let me say, I'm going to put a display link callback. And we will store these guys instead. And make display link callback. And then it's just a matter of saying IT value callback, IT key. Of course, I may be totally wrong about this, and the problem is something different. I'm kind of giving into paranoid voodoo right now, to be honest. But let's see. You don't like that. There's no constructor for this guy. Sure, I'll add a constructor. Whatever. I gotta work on function at some point. It's like one of my least favorite classes in the system. It kind of works most of the time, so I never take the time to fix it up. Raf. Nope, still having problems. Okay, well, my paranoid voodoo did not solve anything. That's good to know. So, what's going on then? Request animation frame, and we got the callback with link ID 1. And then we are calling this again with some new thing. And then when we get the callback, then we try to notify. What are we trying to notify? Maybe we should log everything that's in there then. Display link, notifying, callbacks, size, callback, just log the link ID. Okay, we need to slim down this build command here a little bit because it's getting irritating to wait for it. Apps, browser, and let's also get libweb. Oh, dang it. Tab tools, visual builder. Okay, so, okay. I need to make a hyperlink to ref. So what's going on here? Notifying one callback. All right. Then, oh shit. Oh, dude, we are modifying this while iterating it, obviously. That's the problem. Okay, so let me undo all of my paranoid voodoo. And now that I realize this super obvious mistake I'm making, because the callback that we invoke here may actually mutate the callback map. So we got to make a copy of it, for example. I mean, there are different ways you can iterate data structure that's being modified, but the easiest way is to just make a copy, right? So copy of callbacks. That should work better. We can't copy these. Because we have a function in there and it's non-copyable. Alright, fine. What's the easiest way out of this situation? Let's make, okay. Let's go back to the display link callback, but if we make it ref counted, then we can make a copy of the callbacks list. Wait. This is stupid. Or is it stupid? It's kind of stupid. No, we'll do that. this will not be perfect. There will be room for improvement, but we'll simplify this like this for now. Or simplify is the wrong word, but we just gotta get out of this situation. So function void i32. Maybe we'll make something like invoke. Might as well store this here too then, since we're doing this now. So link ID. Link ID. All right. So we get these, and then in here we'll store ref footer to display link callback. Because now I can make copies of you jerk. Oops. Now we just have to say it dot value dot invoke. Yeah, that's fine. And then here we gotta create one of these guys. So display link callback. Oof. What did I forget? More parentheses. All right. Oh, okay. So it updates when I move the cursor. That's kind of weird. Oh, because it doesn't repaint. Well, we need to teach the canvas element to repaint if something changes. So how do we do that? I guess we just say in the rendering context 2D, we should make a helper probably. So we'll say something like did draw. Did draw, it's fine. We can save this rect. So rect, auto, rect, something like this. And then we'll have an internal thingy here called didDraw. And what he will do is just, we could coalesce these in various ways, right? To try to avoid unnecessarily notifying outer systems that we are repeatedly drawing. But right now we can just say if m_element has no layout node, say if no element, then return. If no layout node, return m_element layout node set needs display. Oh shit, we don't even need the rect. But we should say fix me. Make use of the rect to reduce the amount of invalidated area when possible. Yeah. So now when you draw into a 2D context, it will notify the layout tree that it needs to re-render the layout node for the canvas. Seems like I'm not going to make a link to this thing, but there we are. So this is now updating at whatever the update frequency of the Windows server is, which is pretty cool, actually. So it'll just get just as many callbacks as the Windows server produces, basically. Although it will never drop any callbacks because there's no such concept of like dropping IPC. Maybe there should be something like that. I don't know exactly how that would work. I guess like if you have two of these in the event queue, for example, then we could throw away one of them and only give you one. Yeah, you could probably coalesce these, but because I think there's no expectation that you're going to get some specific amount of these. You're not supposed to rely on that. Because when you use this, you're supposed to rely on like monotonic time and stuff like that instead. Instead of expecting like, oh, this callback will happen this often. That's why I can update my physics that way and so on. Because, well, whatever. This is cool. It's a little bit CPU heavy, but let's see what it looks like here in the stacks. Or, you know, let's use the profiler. Actually, that's way cooler. So, wait, I forgot that we don't have grep. Profile, PID20, enable. And disable. Okay, so I'll stop you. And then we'll take a look. So here we can see the from the event loop, we get a message from the Windows server. It's a display link notification. And in response to that, then we go into display link notify, and then we call the callback that was registered by web document, which calls a JavaScript function, which, you know, goes into libjs and does the JavaScript thing. And of course, we also have the paint message being handled, but like most of the time here is spent in the display link notification or below it. And then we also have time here in regular paint handling. So re-rendering the canvas. Where are you, canvas thing? I guess it's here. And the blit and everything. Well, okay. So it looks exactly like you would expect. You know, it's a little fudgy when you look at profiles like this because the compiler optimizes some things, which makes the stack not look perfectly like it's supposed to, because some things get optimized around, but it basically looks like you would think it should. Very, very nice. So let's commit some stuff. Let's see. Sorry about the lame demo, by the way. I don't know. I don't know what to make a requestAnimationFrame demo. Maybe somebody could make some nice demos eventually, and we can integrate those in testing. But at least this thing does the job of testing the feature, so that's cool. Let's add some stuff. Oh, and let's add a link to that page before I forget, because it's annoying. requestAnimationFrame test. So we'll add those guys, and really everything from Windows Server. Yeah. Windows server plus libgui. Add a way to get notified. Add a way to get notified at screen refresh rate. And display link, GUI display link to get notifications. Oh, what do we call it? That GUI display link notifies you at screen at display refresh rate. This line is too long. Add a way to get notified. Yeah, well, fine. It'll be that way. GUI display link. A mechanism for registering a callbacks that will fire at the display refresh rate. Since we don't note that we don't actually know the screen refresh rate, but this is instead completely driven by the Windows servers, compositing timer. For all current intents and purposes, it does the job well enough. And put one of those guys. So let's see, that's pretty good. And then what do we have left? libweb. Add requestAnimationFrame. Add a basic support more. This we now support ref driven by GUI display link callbacks. It's a bit strange how we keep registering new callbacks over. That's something we can definitely optimize. But this allows you to update animations, whatever, without doing it more often than the browser can display. Okay. I guess we could also implement the, what was it called? A clear animation frame or something like that. Since we're on a roll here, we might as well do the corresponding cancel animation frame API. So we just give it the ID, and this ID, we should abstract this ID actually, because maybe you would have other display links in your program, so it's kind of not cool for JavaScript to get access to all the display link stuff. Also, we should get rid of these noisy debug output here actually. Bam. Oh, we'll just squash that into the previous one. That'll be okay. So, yeah, we're going to need to come up with our own IDs. It's not cool to do this, but for now, we're going to do it anyway. Fix me, we'll say. Don't hand out raw display link IDs to JavaScript. But today we'll do it. And this will be the same basic concept as up here. I'm just going to copy this because it's a mouthful. And what does he return? He probably doesn't return anything. We'll say that he returns JS undefined. And we'll do GUI display link unregistered callback. Arguments 0 to by 32, something like that. Fix me. We should not be passing untrusted numbers to display link unregistered. Okay. Oh, we don't need to capture this here. Okay, and then how do we test this? I guess we're just going to test it with some silly little thing. Ref, cancel animation frame. So if this works, then we shouldn't actually get any animation frame because it gets canceled. Seems to work. Cool. Now I'm not going to commit it that way because I like that it works. But we can do this. So lib web. Add cancel and implement cancel animation frame. Both request animation frame and these functions ref and calf need should eventually stop using raw IDs from GUI display link as their identifiers. That is a fix me for now. Okay. Very cool. So I think that's going to be it for today's video. So if you made it this far, then I thank you for watching, and I don't know what happened here. We're going to get a new terminal. And I hope you saw something interesting. And it was fun today. We got to implement some like functionality in the system that we needed, not just work on the browser or the web or libjs, but like Windows Server stuff, libGUI stuff. And this is what makes this project so great, right? That it's literally a full stack project. Like it's the most full stack project I know of, and I really like it. So this is really fun, this kind of stuff. So thank you for hanging out while I work on it, and I will see you next time. Bye.